Hi, I'm Mike Lopresti, professional engineer and founder of the Fuel and Tire Saver Systems Company. I'd like to talk about tire oxidation. What is tire oxidation? Well, it's really the science of tire aging. What happens with a traditional tire? How do we make them last long? And why does it work? The Fuel and Tire Saver Systems Company provides a service we call tire optimization. What that means is through successive monthly visits, we can inspect a tire, measure the tread depth, analyze the data we achieve, and look at tire set pressures to provide optimum set pressures to extend the life of a tire. Our results have shown that we can make a standard tire last 30 to 80% longer, and yes, in some cases, we've made a tire last twice as long. In fact, we have a Ford F-150 that those tires will last 85,000 miles. Now let's talk about tire oxidation. What does that mean? Well, most tires are filled with compressed air. Compressed air is simply the air we breathe outside, compressed to a pressure and put inside a tire. The problem is regular compressed air is comprised of 79% nitrogen, about 20% oxygen, and lots of moisture and water. The problem is oxygen happens to be very damaging to rubber. Let's take a look at a regular rubber band. You set a rubber band out, what happens? Over time, it becomes very brittle, and that's because it's attacked by oxygen in the air as well as ozone, but the oxygen actually causes rubber to be brittle. So over time, what you'll see is it starts to fracture and then it quickly snaps and it does not have much elasticity. So as rubber ages, oxygen attacks the rubber and then it causes it to be less pliable. Same thing happens with tires. As a tire ages, you will see that the rubber gets very stiff and then starts to wear rapidly. As a better illustration, let's look at these 4 foam blocks. A new tire, we call that the virgin tire, it actually responds very quickly and rebounds to any load applied to the sponge block. Okay? As a tire ages, you'll find the oxygen starts to take over and it becomes much stiffer. Stiffer to push down, but also does not spring back as much. That spring back effect is called hysteresis, and that's very important in tires. It's very important in the life of a tire and how a tire responds. In fact, tire engineers have studied this extensively, and they know that the secret to a tire is its spring back ability. So as the tire ages and oxidizes, what typically happens, it becomes stiff. As time goes along, it's much stiffer. So now you can't push that down and it responds very, very slowly until ultimately a fully oxidized tire is just very stiff and does not give at all. When a tire reaches this age or this level of oxidation, what happens? That tire doesn't spring back, tread tends to wear uneven and actually quickly. How do we prevent oxidation within a tire? Well, with our patented tire optimization service, we come out every month and we continually inflate tires with our 99% pure Astrea nitrogen. That Astrea nitrogen has very little oxygen, virtually none, and very little moisture. So what happens? We add pure nitrogen into the tire, the smaller oxygen molecules actually permeate through the rubber, and over a short period of time, we can increase the concentration of the gas inside the tire to 95% nitrogen. At that level of concentration, we can get tires to last 30 to 80% longer, all the while reducing your fuel use by 12 to 15%. Fuel use is reduced because with proper tire inflation, the rolling resistance of the vehicle is decreased. Lower rolling resistance means that the engine in the vehicle or the motor, if it's an electric car, needs less force to propel the vehicle forward. Take, for example, the regular school bus. We've shown that we can save considerable amount of fuel with a regular school bus. In one study, over 16 months, we saved 227 gallons of fuel. And at today's price of gas, or in this case, price of diesel, you'll find that we can save over $500 per bus per year for each school bus. and that's after our cost. So that's like putting $500 per bus each year right back into the budget for that school. But let's take a closer look at oxidation. What happens? Well, when you have a tire filled with compressed air, you find that the 20% of oxygen, and in this example represented by the blue, actually just mixes in with the air. But what is not known is that oxygen is actually a heavier molecule than nitrogen. So what happens as the tire continues to rotate? So remember, with compressed air, every time you fill a tire up, you're actually just adding proportionally more oxygen back into the tire. I'm going to illustrate a rotating tire with this standard battery-operated drill. As you can see, as the tire begins to rotate, the oxygen just mixes around and moves freely within the tire. But over time, what happens? As the speed of the tire increases, you will see that the oxygen, being heavier, aligns right to the exterior wall of the tire. And that means the oxygen is further pushed through the tire, causing the rubber to accelerate oxidation of the rubber. And as you continue to add compressed air into a tire, what happens? More oxidation occurs. More oxidation occurs, tires become stiffer, which means this, not this, and tires age and wear rapidly. We'd love to help you increase the safety of your fleet, reduce your fuel use, and consequently reduce your fuel costs, leading to more profits for your business while extending the life of your tires 30 to 80%. Reach out to us. And in the meantime, happy driving.